Hi, my name is Muhammad Iqbal bin BULMENG. My student ID B0919103332 and my supervisor is TS Dr. Muhammad Fauzi bin Muhammad. Welcome to my presentation, to my panel and all the viewers. So today I'm going to present my bachelor degree project 1 titled Investigation on the Mechanical Properties and Corrosion Behavior of Low Carbon Steel Substrates in Malacca River. And this is the outline that I will present after this. In the Malacca River, corrosion threatens the long-term performance and integrity of low-carbon steel structure. So in this study, we choose low-carbon steel substrates because many structures built in the Malacca River use low-carbon steel. For example, jetty, platform, and steel structure. Other than that, river water quality is closely linked to corrosion. So in this study, we will look at the water quality of each study area we have selected. Therefore, engineer must consider corrosion a long-term danger to steel structure during the design phase. There are three problem statements in this study. First, in the Malacca River, many steel structures have rusted and almost rotted. This situation can cause the lifespan of structure built on the river to be short. Second, the increase in human activities around the river, especially in the Malacca River, because this place is one of the tourist locations in the state of Malacca. This increase in human activity can cause river water pollution. Third, corrosion in river water occurs due to the content of river water. Each river water area has a different water content that can change the corrosion rate. But it is not easy for us to determine which river area have river water content with high corrosion rate. So the aim of this study is to predict the lifespan of low carbon steel in three different locations, namely Batu Hampar, Taman Rempah, and Muara Sungai Melaka. The first objective of this study is to study the corrosion effect of three different river water locations, namely Batu Hampar, Taman Rempah, and Muara Sungai Melaka on a low-carbon steel structure. Second, to observe the effect river water content of Malacca River to corrosion rate on low-carbon steel. And third is to investigate the uniform and localized corrosion that occur on the sample surface after corrosion test. There are 7 scopes in this study. First, using the river water from the Strait of Malacca as an electrolyte. Second, to study corrosion behavior via an immersion test in the sample of water river from 3 different locations. Third, divide sample into 3 different locations, which is Batu Hampar, Taman Rempah, and Muara Sungai Melaka. Fourth, using bandsaw cutting machine to cut the substrate material to the diameter of 25 times 10 mm. Other than that, use a hardness test and an optical microscope to perform mechanical testing on the substrate. And then, all samples were immersed in the water river for 7 days, 14 days, 21 days, 28 days, and 35 days. Lastly, using a scanning electron microscope (SEM) or energy dispersive X-ray (EDX) to study the corrosion behavior on the substrate surface after a test. The next topic is literature review. So there are 3 types of low carbon steel. That is low carbon steel, medium carbon steel, and high carbon steel. These 3 carbon steel have different carbon content and different strength. Corrosion is when a refined metal is naturally converted to a more stable form, such as its oxide, hydroxide, or sulfide state. This leads to deterioration of the material. Corrosion occurs when a metal with a higher reduction potential or a lower noble metal is present in a particular environment. The figures show how corrosion can occur. There are many types form of corrosion, which is uniform, crevice, galvanic, pitting, erosion, and intercrystalline. The classification of corrosion is based on how it manifests on rusted metallic surface. In most circumstances, rust may be observed with the naked eye, but in other instances, magnification is required. Corrosion is also caused by water characteristics. Corrosion is usually caused by water with a low pH. Corrosion is accelerated in acidic water because there are more hydrogen ions in the water to react with the electron at the cathode. Other than that, corrosion is also caused by water quality. In Malaysia, urbanization process and population growth have contributed to an ever-growing demand for water while also raising water pollution level in Malaysia. Water quality as well as availability to water in general is a key challenge in Malaysia. Rivers are important to both nature and human society in Malaysia. In the Malacca River is well known for its river cruise activity, allowing travelers to see the beauty and historical sites along the Sungai Malacca Inland Canal at a moderate cost. This activity also has Malacca positioning as a historical tourism destination. However, this activity is hampered by the state of Sungai Malacca, which is still classified as moderately polluted with a water quality index of 70% in 2015. In this study, we have selected three places in the Melaka River, namely Batu Hampar, Taman Rompa, and Muara Sungai Melaka. In Batu Hampar, several structures have been built, including tidal control gate and garbage trap. The structure that was built looks rusty due to corrosion. In Taman Rompa, several constructions, including a jetty and a bridge, have been constructed in this area. Corrosion has rusted the bridge structure. In Muara Sungai Melaka, many structures have been built using steel. The condition and quality of river water in this area may differ from other rivers due to the mixing of river water and seawater. This is the corrosion behavior of low-carbon steel in different mediums and locations from previous study. The next topic is research methodology. This is the flowchart that I will follow during this study, starting from specimen preparation until thesis submission. For sample preparation, we will use benzo cutting machine to cut the low-carbon steel substrates with size 25 times 10 mm. For mechanical testing, we will use four types of machine. First is mounting metallography press machine. This machine is to encapsulate metal and other material specimens, especially one small specimen with a mounting compound and appropriate mounting resin. The second machine is metallographic polishing machine. This machine to achieve the flat sample with a little damage of the sample surface as possible. The third machine is optical inverted research microscope. This machine is to analyze the microstructure of low carbon steel. And the last machine is Rockwell hardness testing machine. This machine is to evaluating hardness strength of a material when testing extremely tiny or thin samples. For river water sample preparation, I will take river water from three different locations, that is Batu Hampar area, Taman Rempa area, and Muara Sungai Melaka area. After that, I will check the pH value of each river water using a digital pH meter. So the pH of river water indicates how acidic or basic the water is. For immersion test, the sample has been subjected to a corrosion test in 3 river water from different locations and 1 distilled water. The immersion test will be carried out by 7, 14, 21, 28, and 35 days. The purpose of this test is to predict material resistance to corrosion and evaluate a material's behavior in a specific corrosive environment. After going through a corrosion test, I will do a surface analysis for the substrate. So, for this analysis, I will use two different types of machine. The first machine is scanning electron microscopy (SEM). This machine is to analyze the material structure at the level of micro. And the next machine is energy dispersive X-ray (EDX). This machine is to identify the elemental composition of materials. The last topic is preliminary finding. So this is my expected result. My expectation for the study is that river water with a low pH value will show a high corrosion rate. Water is considered highly corrosive if the pH falls between 6.0. If the pH is between 6.0 and 6.9, the water is probably corrosive and stagnant testing is recommended. If the pH is between 7.0 and 7.5, the water is not likely to be overly corrosive. So the graph shows a comparison of corrosion rate between 3 locations. This is my Gantt chart for PSM1, starting from week 1 until week 16. And this is my Gantt chart planning for PSM2, starting from week 1 until week 16. This is the list of references that I used in this study. So that's all from me. Thank you for watching.